Hello, hello, my dear children. Welcome to the mathematics class. Today we are going to discuss conic sections. In this chapter, we have discussed the concepts of exercise 11.3 in the previous class, and we have discussed some questions based on the concepts of exercise 11.3. That is the concepts of ellipse and the sums on ellipse we have discussed in the previous class. I hope you have understood the concepts of ellipse, and I hope you have learned well the sums based on the ellipse, and I hope you have done the first 5 sums in the exercise 11.3. Haven't you, my dear children? Right. Now come to the concepts of exercise 11.4. In this exercise, we mainly concentrate on the fourth kind of conic sections, that is hyperbola. We discuss in this exercise hyperbola. Okay, my children, are you ready to listen the class? Right. Hyperbola. Let us discuss what is the definition of hyperbola. Okay, my children. A hyperbola is the set of all points in a plane, the difference of whose distances from two fixed points in the plane is a constant. See the figure 11.29. Okay, my children. In the previous class, we have discussed ellipse. Do you remember the definition of an ellipse, my children? Yes, an ellipse is the set of all points in a plane, the sum of whose distances from two fixed points in the plane is a constant. In that case, the sum of the distances from two fixed points in the plane is constant. Whereas in the case of hyperbola, the sum of the difference of the distances from two fixed points in the plane is a constant. Okay, my children, understood this difference between ellipse and hyperbola? Right. Now, observe this figure 11.29. Okay, my children. In this hyperbola, in this figure, F1 and F2 are two fixed points in the plane. Okay, my children. And let us consider this is P1, this is P2, and this is P3. These are the points in the plane such that the difference of whose distances from these two fixed points F1 and F2 is constant. Understood this point, my children? Right. That is P1 F2, P1 F2 minus P1 F1. P1 F2 minus P1 F1 is equal to P2 F2 minus P2 F1. That is equal to P3 F1 minus P3 F2. This is the condition. This is the definition of the hyperbola. Understood this statement, my children? The difference of whose distances from two fixed points in the plane is constant. The difference, this difference, and this difference. All these differences are equal. Okay, my children, understood this point? Right. Here we are going to discuss center, conjugate axis, transverse axis and the vertices of a hyperbola. Okay, my children. In the case of ellipse, we have discussed the center, the major axis, minor axis, and the vertices of an ellipse. Do you remember that points, my children? Right. Similarly, here also we discussed the center, conjugate axis, transverse axis, and vertices of a hyperbola. Okay, my children? Right. The term difference that is used in the definition means the distance to the further point minus the distance to the closure point. The two fixed points are called the foci of the hyperbola. The midpoint of the line segment joining the foci is called the center of the hyperbola. The line through the foci is called the transverse axis, and the line through center and perpendicular to the transverse axis is called conjugate axis. The points at which the hyperbola intersects the transverse axis is called the vertices of the hyperbola. Understood these points, my children? What is meant by center of hyperbola? What is meant by conjugate axis? What is meant by transverse axis? And what are called vertices of the hyperbola? See the figure 11.29. In this figure, we have discussed previously. These are the two fixed points, F1 and F2. These are the two fixed points. Okay, my children, right. P1, P2 and P3. These are the points on the hyperbola. Here difference in the definition of hyperbola means the distance to the further point minus the distance to the closure point. Like this we have to take the difference. Okay, my children. Then these two fixed points are called foci of the hyperbola. And the midpoint of the line segment joining these foci is called the center of the hyperbola. Understood this point, my children? What is meant by center of the hyperbola? Next, the line through the foci is called the transverse axis. This is called transverse axis. This line, the line which passes through the foci of the hyperbola is called transverse axis. Okay, my children? Understood this point? And the perpendicular to the transverse axis and passing through the center is called conjugate axis. Okay, my children? This line is passing through the center of the hyperbola and perpendicular to the transverse axis. This line is called conjugate axis. Okay, my children, understood this point? In the case of ellipse, we have discussed major axis and minor axis. Whereas in the case of hyperbola, we have to remember these axes. That is the transverse axis and conjugate axis. Okay, my children? Right. The points at which the hyperbola intersects the transverse axis are called the vertices of the hyperbola. See, this is hyperbola. Okay, my children. This hyperbola is intersecting the transverse axis at this point and at this point. At these 2 points, hyperbola is intersecting the transverse axis. So these 2 points are called vertices of the hyperbola. Understood these parts of an hyperbola, my dear children? Right. We denote the distance between the two foci by 2c. The distance between the two vertices means the length of the transverse axis by 2a, and we define the quantity b as b is equal to root of c square minus a square. Also 2b is the length of the conjugate axis. See the figure 11.30, my dear children. So in this figure 11.23, observe these are the two fixed points F1 and F2 in the plane. So the distance between these two fixed points, that is the distance between the two foci of this hyperbola, is denoted by 2c. Okay, my children, please remember these points well. Next, we denote the distance between the two vertices. What are the vertices of the hyperbola? Here point A and point B. So the distance between these 2 points A and B is denoted by 2A. So the length of the line segment AB is equal to 2A, and this is also called length of the transverse axis. Length of the transverse axis of the parabola is equal to 2A. Please remember this point, my children. And we define the quantity B as root of c square minus a square. This is the relationship between a, b and c of hyperbola. Okay, my children. Also 2b is the length of the conjugate axis. Say in the case of ellipse, we denoted the length of the major axis is 2a and the length of the minor axis is 2b. Yes or no, my children? Do you remember that point? Similarly, here the length of the transverse axis is 2a and the length of the conjugate axis is 2b. Please remember these points, my children. Okay, my children, understood these points? Right. Now, let us find the constant. That is P1 F2 minus P1 F1. What is the value of, we have taken the point P. So P1, suppose here we have taken a point P1 F2 minus P1 F1. Let us find the value of this difference. Okay, my children, right. By taking the point P at A and B in the figure 11.30, we have BF1 minus BF2 is equal to AF2 minus AF1 by the definition of the hyperbola. Okay, my children, if you take the point P at these vertices of the hyperbola at these points, then how do you define in that definition, in this difference, the place of P1, write B and A, the farther point first. So BF1 minus BF2 is equal to AF2 for this point F2. It is a farther point. A is a farther point. So AF2 minus AF1. As for number children, these are the points on the hyperbola. So by the definition of the hyperbola, we have taken this step. Understood this step, my children? Right. This implies BF1. Observe this figure, my children, 11.30. Here BF1 can be written as BA plus AF1. So now, my children, observe this figure, my children, minus BF2. We wrote this second term as it is equal to, here AF2 is written as AF2. Observe this figure, my children. AF2 can be written as AB plus BF2. Yes, sir, my children. So we wrote AF2 as the sum of these two line segments minus AF1. Understood this step, my children? Right. This implies BA plus AF1 minus BF2 is equal to AB plus BF2 minus AF1. Here we remove the small brackets. After removing the small brackets, we wrote these three terms in LHS and we wrote these three terms in RHS. Understood this step, my children? Right. Here on both sides, here AB cancelled. AB gets cancelled. Yes or no, my children? Understood this point, my children? Right. AB both will get cancelled. Then what are the terms left here? A1 minus BF2 is equal to BF2 minus AF1. Okay, my children, let us rearrange the terms. Means let us transpose minus AF1 to LHS and minus BF2 to RHS. Okay, my children. Then what will you get here? This implies AF1 is equal to BF2. Yes or no, my children? Because in LHS we get 2AF1. Yes or no, my children? Is equal to 2BF2. So by striking out the 2 on both sides, finally we get AF1 is equal to BF2. Okay, my children? We use this result in the next step. Okay, my children? Understood this step? AF1 is equal to BF2. See this figure, AF1 is equal to BF2. These two distances are equal. Okay, my children? Right. So that BF1 minus BF2 is equal to BA plus AF1 minus BF2. Okay, my children? Here let us take this statement. Let us take this expression. BF1 minus BF2 is equal to, previously we wrote BA plus AF1 minus BF2. Okay, my children, understood this step? Right. That is equal to BA plus BF2 minus BF2, because we have proved that AF1 is equal to BF2. Here we have proved that AF1 is equal to BF2. Yes or no, my children? We are using this result in this step. In the place of AF1, we wrote BF2. Understood this step, my children? Right. That is equal to BA plus BF2 minus BF2. Understood this step, my children? I removed the small brackets. Then I wrote these three terms. Then we get BA plus BF2 minus BF2. Okay, my children. Here BF2 minus BF2 gets cancelled. Understood this step, my children? Right. That is equal to BA. What is here BA? The length of the line segment join the two vertices of the hyperbola. We denoted it as 2A. Yes or no, my children? Right. That is equal to 2A. So we found here the difference BF1 minus BF2 is equal to 2A. It is nothing but the length of the transverse axis. Okay, my children, we have found that constant. In the definition, we have defined the difference of whose difference is from two fixed points is a constant. That fixed constant, that constant value is 2A. Understood this point, my children? Right. In the case of ellipse, we have defined eccentricity. Here also, in the case of hyperbola also, we define eccentricity. Okay, my children, eccentricity of the hyperbola. Let us see the definition. Just like an ellipse, the ratio E is equal to C by A is called the eccentricity of the hyperbola. Since C is greater than or equal to A, the eccentricity is never less than 1. Okay, my children. In terms of eccentricity, the foci are at a distance of AE from the center. Okay, my children. Understood this definition? Same as in the case of ellipse. C is equal to C by A. Do you remember the formula to find eccentricity of an ellipse, my children? Here also same, E is equal to C by A. Eccentricity E is equal to C by A. But here the value of C is greater than or equal to A. So eccentricity of an hyperbola never less than 1. Whereas in the case of ellipse, eccentricity of an ellipse is less than 1. Please remember this point, my children. Eccentricity of an ellipse is less than 1, whereas eccentricity of an hyperbola is greater than 1. Okay, my children. In terms of eccentricity, the foci are at a distance of AE from the center. Okay, my children. So we define the foci, the coordinates of foci in terms of eccentricity as plus or minus AE comma 0. Same as in the case of ellipse, here also we can define the foci of hyperbola in terms of eccentricity like this. Okay, my children, understood this point? Right. Now come to the standard equation of hyperbola. In the case of ellipse, we have discussed standard equation of an ellipse. See, similarly here also we discuss the standard equation of hyperbola. The equation of a hyperbola is simplest if the center of the hyperbola is at the origin and the foci are on the x-axis or y-axis. Okay, my children. The hyperbola should be in this standard position. A hyperbola is said to be in the standard position if center of the hyperbola is at the origin and the foci should lie either on x-axis or on y-axis. Then the hyperbola is said to be in the standard position. Then the equation of the hyperbola is said to be standard equation of the hyperbola. Understood this point, my children? There are two cases. The two such possible orientations are shown in the figure 13.31. Please observe these figures, my dear children. 13.31a, this is 13.31a and this is a 13.31b. In this 13.31a, the transverse axis is along the x-axis and the conjugate axis of the hyperbola is along the y-axis. Whereas in the case of 11.31b, here the conjugate axis is along the x-axis and the transverse axis of the hyperbola is along the y-axis. The transverse axis of the hyperbola is along the y-axis and the conjugate axis of the hyperbola is along the x-axis. Okay, my children. Please remember these points. Then the equation of the hyperbola is x square by a square minus y square by b square is equal to 1 in this first case. And vertices of the hyperbola are minus a comma 0 and foci are plus or minus c comma 0. Okay, my children. Whereas in the case of 11.31b, the equation of the hyperbola is y square by a square minus x square by b square is equal to 1. Please remember these equations, my children. These are standard equations of the hyperbolas. Okay, my children. In this case, in this second case, the coordinates of vertices or 0 comma a 0 comma minus a, and the coordinates of the foci are 0 comma c 0 comma minus c. Okay, my children, please remember all these points well, which are very useful in solving the sums in the exercise. Okay, my children, right. Note, a hyperbola in which a is equal to b is called an equilateral hyperbola. Okay, my children, it means if the length of the transverse axis is equal to the length of the conjugate axis, then the hyperbola is said to be an equilateral hyperbola. Okay, my children, this is a definition of an equilateral hyperbola. Okay, my children, please remember this point. Now, discussion from the equation of the hyperbola. We have obtained it. Follows that we have for every point x comma y on the hyperbola, x square by a square minus y square by b square is equal to 1. This implies x square by a square is equal to 1 plus y square by b square. Here we have taken the standard equation of hyperbola. From this equation, we get x square by a square is equal by transforming this is second term to RHS. What will get? X square by a square is equal to 1 plus y square by b square. Understood this statement, children? Right. If you observe this RHS, 1 plus, here it is a positive number, square is there, so it is a positive number. So the value of x square by a square is greater than or equal to 1. That's what my children. Understood this point? Right. This implies x square by a square is greater than or equal to 1. Here we are writing 1 plus some positive value. So 1 plus some positive value means this is greater than 1. Therefore, x square by a square value is greater than or equal to 1. Understood this statement, children? Right. This implies by taking square root on both sides, we get modulus of x by a is greater than or equal to 1. Okay, my children, by taking the square root on both sides, we get modulus of x by a is greater than or equal to 1. This implies mod x is greater than or equal to mod a, because mod a by b is equal to mod a by mod b. By using this formula in the LHS of this inequality, we get mod x by mod a is greater than or equal to 1. So by cross multiplication, finally we get mod x is greater than or equal to mod a. Understood this statement, children? Right. This implies x is less than or equal to minus a, or x is greater than or equal to a. Okay, my children, here we use this modulus function condition. Modulus of x is greater than or equal to a implies x is less than or equal to minus a, or x is greater than or equal to a. By using this result, we wrote this step. Understood this step, my children? Right. Therefore, no portion of the curve lies between the lines x is equal to a and x is equal to minus a. That is, no real intercept on the conjugate axis. Okay, my children. Here, by this step, we say that no portion of the curve lies between the lines x is equal to plus a and x is equal to minus a. Okay, my children. Similarly, we can derive the equation of the hyperbola in figure 11.231b as y square by a square minus x square by b square is equal to 1. Observe this figure, my children. Here, in this case also, we observe that no portion of this curve, no portion of this hyperbola lies between x is equal to y is equal to, here in this case y is equal to a and y is equal to minus a. Between these two lines hyperbola does not lie. Understood this point, my children? Right. The above mentioned two equations are said to be standard equations of the hyperbolas. Please remember the standard equations of the hyperbola, my dear children. X square by a square minus y square by b square is equal to 1, and y square by a square minus x square by b square is equal to 1. These are the standard equations of the hyperbola. Okay, my dear children, right. Note, the standard equations of hyperbolas have transverse axis and conjugate axis as coordinate axis, and the center is at the origin. However, the hyperbolas with any perpendicular lines as transverse and conjugate axis, but the study of such cases will be dealt in higher classes. In this class, we study the hyperbolas in the standard position. Means we study the hyperbolas whose transverse axis and conjugate axis are coordinate axis and their center is at origin. There are some cases whose transverse axis and conjugate axis are not coordinate axis and their center is not at origin. Such cases are there also there, but we don't study such kind of hyperbolas in this class. We study such kind of hyperbolas in the higher classes. Okay, my children, understood this point? Right. Now come to observations. By observing the standard equations of hyperbola, we notice these 2 points. See the first point, from the standard equation of hyperbola, see the figure 11.29. Observe the figure 11.29. We have the following observations. Okay, my children, we observe these points from the figure 11.29. Hyperbola is symmetric with respect to both the axes. Since if ordered pair x comma y is a point on the hyperbola, then ordered pair minus x comma y comma ordered pair x comma minus y and ordered pair minus x comma minus y are also points on the hyperbola. By observing the figure 11.29 well, you notice this point, that is hyperbola is symmetric about both the axes. Okay, my children, if the point x comma y lies on the hyperbola, then the remaining 3 points minus x comma y, x comma minus y and minus x comma minus y are also the points on the hyperbola. Okay, my children, this is the observation we find from the figure 11.29. Okay, my children, understood this first observation? Right. Now come to the second observation. The foci are always on the transverse axis. So, my children, observe the figure 11.29. We find that the foci are always on the transverse axis. It is a positive term whose denominator gives the transverse axis. By observing the equation x square by a square minus y square by b square is equal to 1. In the equation, which is a positive term? Yes, x square by a square is a positive term. So it gives the transverse axis. because in the numerator x square is there, so transverse axis is x axis. In the case of y square by a square minus x square by b square is equal to 1 in the second case, then what is the positive term here? Y square by a square is a positive term. Yes or no, children? In this equation, y square by a square minus x square by b square is equal to 1. Y square by a square is a positive term. So here y square is there in the numerator. So transverse axis of the hyperbola is y-axis. Please remember this point, my children. Understood this point, my children? Right. Let us take an example to understand this point well. How to find the transverse axis of a given hyperbola. Observe this example, my children. X square by 9 minus y square by 16 is equal to 1. If you observe this equation, in this equation, in LHS, what is the positive term? X square by 9 is a positive term. Yes or no, my children? So, in the numerator x square is there. So, its transverse axis is x axis. Transverse axis is along the x axis. And length of this here, this is a square value. A square value is 9. Then what is the value of a? 3. Yes or no, my children? So length of the transverse axis is 2a, that is 2 into 3, that is equal to 6 units. Understood this example, my children? Right. Let us take another example. Y square by 25 minus x square by 16 is equal to 1. Understood this equation, my children? Observe this equation well, my children. In this equation, in LHS, what is the positive term? Y square by 25 is a positive term. So in the numerator, y square is there. So the transverse axis of this hyperbola is along the y-axis. Understood this point, my children? And the length of the transverse axis is here. What is this one? A square. This number denotes a square value. So a square is equal to 25. Then what is the value of a? 5. So the length of the transverse axis is 2a units. So 2 into 5, that is equal to 10 units. Understood this point, my children? Right. In the case of ellipse, we have discussed latus rectum. Here also we discuss latus rectum of an hyperbola. Okay, my children? Come to the point, latus rectum of an hyperbola. See the definition of latus rectum of a hyperbola. Latus rectum of hyperbola is a line segment perpendicular to the transverse axis through any of the foci and whose endpoints lie on the hyperbola. As in ellipse, it is easy to show that length of the latus rectum in hyperbola is 2b square by a. Same as in the case of ellipse. How do you define the latus rectum of an ellipse? Yes, it is also a line segment which is perpendicular to the major axis and passing through any one of the foci. Yes or no, children? Do you remember that definition of latus rectum of an ellipse? Right. Similarly, here we define latus rectum of an hyperbola is a line segment which is perpendicular to the transverse axis and it is passing through any one of the foci, and the endpoints of the line segment lie on the hyperbola. Okay, my children? Right. So, as in the case of ellipse, here also we can show that easily length of the latus rectum of the hyperbola is 2b square by a. Okay, my children, this is the formula to find the length of the latus rectum of a hyperbola. Okay, my children, please remember this formula well. Memorize this formula well, my dear children. Okay, my children? Right. These are the points related to hyperbola. Now let us take some example to understand these concepts on the hyperbola. Okay, my children, right. See this example. Find the coordinates of the foci and the vertices, the eccentricity, the length of the lattice rectum of hyperbola x squared by 9 minus y squared by 16 is equal to 1. Okay, my children, understood this question? Equation of an hyperbola is given. Then we have to find coordinates of the foci, coordinates of the vertices, eccentricity of the hyperbola, and length of the lattice rectum of the hyperbola. We have to find all these four values. Okay, my children. If you observe this equation of the hyperbola, it is the standard equation of the hyperbola. Okay, my children, like this. The positive term of this hyperbola is x square by 9. So here x square is there. So we conclude that the transverse axis of this hyperbola is along the x-axis. Understood this point, my children? Right. Now come to the solution part. Comparing the equation x squared by 9 minus y squared by 16 is equal to 1 with the standard equation x squared by a square minus y squared by b square is equal to 1. Okay, my children, we are comparing given equation of the hyperbola with the standard equation of the hyperbola x square by a square minus y square by b square is equal to 1. Then we have a is equal to 3 and b is equal to 4. As I mentioned, because this is a square value and this is the b square value. So a square is equal to 9. Then what is the value of a? 3. Understood this point, my children? Here b square value is 16. Then what is the value of b? 4. Understood these two values, my children? We got to a and b. Now let us find the c value. We have to find the value of c, because to find the coordinates of foci, we should find the value of c. Okay, my children? Right. Now c is equal to square root of a square plus b square. Please remember this relation, my children, between a, b and c of an hyperbola. C is equal to root of a square plus b square. Okay, my children. Whereas in the case of ellipse, c is equal to root of a square minus b square. But here in the case, in the place of minus, we write here plus. Okay, my children, please remember this point. That is equal to, in this formula, let us substitute the values of a and b. So square root of, what is a value? 3. So 3 square plus, what is b value here? 4. So 4 square. Understood this step, my children? That is equal to square root of, what is the value of 3 square? 9. Plus what is the value of 4 square? 16. Understood this step, my children? Right. That is equal to square root of 9 plus 16. What will you get here? 25. So square root of 25. What is the value of square root of 25? 5. Okay, my children, understood this step. So the value of c is equal to 5. We got the value of c. Okay, my children, right. Therefore, the coordinates of the foci is equal to plus or minus c comma 0. Yes, or my children, observe this figure. What are the coordinates of foci? C comma 0 minus c comma 0. That is equal to, we wrote here, plus or minus c comma 0. Okay, my children, right. That is equal to ordered pair plus or minus, what is the value of c here? We found 5. So plus or minus 5 comma 0. These are the coordinates of the foci of the given hyperbola. Understood this point, my children? Right. Vertices, that is equal to, what are the vertices of this hyperbola? Plus or minus a comma 0. Yes or no, my children? So vertices of the hyperbola is equal to plus or minus a comma 0. That is equal to plus or minus 3 comma 0, because what is the value of a here? 3. So vertices of the hyperbola is ordered pair plus or minus 3, 0. Understood this statement, children? Right. Now let us find eccentricity of the hyperbola. Eccentricity is equal to C by A. That is equal to, we have found the value of C. What is the value of C here? 5. 5 by, what is the value of A here? 3. So this is the eccentricity of the hyperbola. Okay, my children. If you observe this value, it is greater than 1. 5 by 3 value is greater than 1. Previously we have discussed this point. Eccentricity of an hyperbola is greater than 1. Okay, my children? Right. The lattice rectum, length of the lattice rectum, that is equal to 2b square by A. Okay, my children, this is a formula to find the length of the lattice rectum. Please remember this formula. In this formula, let us substitute the values of A and B. So that is equal to 2 into B. What is B value here? 4. So 4 square by 3. Understood this statement, children? Right. That is equal to, by simplifying these numbers, what will you get? 32 by 3. This is the length of the lattice rectum. Understood this statement, children? Right. Now let us take another example. Okay, my children? Right. Find the coordinates of the foci and the vertices, the eccentricity, the length of the lattice rectum of the hyperbola y square is minus 16x square is equal to 16. Okay, my children. As we have discussed in the previous example, here also we have to find the coordinates of the foci, the vertices, the eccentricity, and length of the lattice rectum of the hyperbola. Y square is equal to minus 16, x square is equal to 16. If you observe the equation of the hyperbola, this is not in the standard, it is not in the form of standard equation of the hyperbola. Yes or no, my children? So first of all, let us transform, let us convert this equation into the standard equation of the hyperbola. Okay, my children? Right. Now come to the solution part. To convert the given equation into the standard form of hyperbola, let us divide the entire equation by 16, because we should get 1 in RHS. What is there in RHS? 16 is there. So to make this number as 1, we are dividing this entire equation by 16. Understood this statement, children? Then we get y square by 16 minus x square by 1 is equal to 1. Understood this statement, children? Right. Then if you observe this equation is in the standard equation of the hyperbola. Yes or no, my children? Right. Now let us compare this equation with the standard equation of the hyperbola y square by a square minus x square by b square is equal to 1. Okay, my children, we are comparing this equation of the hyperbola with the standard equation of the hyperbola y square by a square minus x square by b square is equal to 1. Then what will you get here? We find that a is equal to 4 and b is equal to 1, because here a square value is 16. So my children, a square, first term, denominator a square. So a square is equal to 16. Then what is the value of a? 4. Understood this value, my children? Similarly, b square is equal to 1. Here second term denominator b square. Here the second term denominator is 1. So b square is equal to 1. Then what is the value of b here? 1. B is equal to 1. Understood these two values, my children? A and b. Right. Now c is equal to root of a square plus b square. Now let us find the value of c. Okay, my children? Right. That is equal to, in this formula, let us substitute the values of a and b. So 4 square plus 1 square. Understood this step, my children? That is equal to square root of, what is the value of 4 square? 16 plus what is the value of 1 square? 1. Understood this step, my children? That is equal to square root of 16 plus 1. What will you get here? 17. So C is equal to root 17. Understood this statement, children? Right. Therefore, the coordinates of the foci is equal to ordered pair 0, comma plus or minus C. Okay, my children. Here these are the coordinates of the foci, because here positive term is y square by 16. So the transverse axis of this hyperbola is along the y axis. That is why coordinates of the foci are ordered pair 0, comma plus or minus C. Understood this point, my children? Right. That is equal to ordered pair 0, comma plus or minus root 17, because we got the value of C. C is equal to 17. Understood this step, my children? Right. Vertices is equal to ordered pair 0, comma plus or minus A. Okay, my children? Right. That is equal to ordered pair 0, comma plus or minus 4, because what is the value of A here? 4. So 0, comma plus or minus 4. Understood this step, my children? Right. The eccentricity is equal to C by A. That is equal to, in this formula, what is the value of C here? Root 17. So root 17 by, what is the value of A here? 4. Root 17 by 4. Here also, if you simplify this number, the value of this number is greater than 1. Eccentricity of the hyperbola is greater than 1. Okay, children? Right. The lattice rectum is equal to 2b square by A. Okay, my children, do you remember this formula to find the length of the lattice rectum of hyperbola? Yes, 2b square by A. So in this formula, substitute the values of A and B. So that is equal to 2 into B means here 1. So 1 square by A value is 4. Understood this step, my children? That is equal to, by simplifying this number, what will get here? 1 by 2. This is the length of the lattice rectum of given hyperbola. Understood, my children? Right. Now let us take another example to understand the concepts of hyperbola well. Okay, my children? Find the equation of the hyperbola with foci ordered pair 0, comma plus or minus 3 and vertices ordered pair 0, comma plus or minus root 11 by 2. Understood this question, my children? Here foci of the hyperbola and the vertices of the hyperbola were given. If you observe the coordinates of foci and vertices, x coordinates of these 2 points are 0. Yes or no, my children? So these 2 points lie on y-axis. Yes or no, my children? These 2 points lie, foci and vertices of the hyperbola lies on y-axis. Therefore, we can say that the transverse axis of the hyperbola is along the y-axis. Okay, my children? Understood this point? Right. Now come to the solution part. Since the foci is on y-axis, the equation of the hyperbola is of the form y square by a square minus x square by b square is equal to 1. Understood this point, my children? By observing the coordinates of the foci and vertices of the hyperbola, we found that the transverse axis of the hyperbola is along the y-axis and the equation of the hyperbola is y square by a square minus x square by b square is equal to 1. Okay, my dear children, this is the required equation of the hyperbola in which we have to find the values of a and b. Understood this point, my dear children? Right. So this is a geometrical representation, visual representation of the given hyperbola. Here vertices and foci are on y-axis. The transverse axis of this hyperbola is along the y-axis. Okay, my children? Right. Since the vertices is equal to 0, comma plus or minus a, that is equal to 0, comma plus or minus root 11 by 2. So now my children, what are the vertices of this hyperbola? 0, comma, plus or minus a. So 0, comma, plus or minus root 11 by 2. We are equating these two. So what will you get here? A value root 11 by 2. Understood this step, my children? We got a value. Now we have to find b value. Okay, my children? Right. Also, since foci of the hyperbola are 0, comma, plus or minus c. So by equating these two coordinates, these 2 points, what we get? C is equal to 3. Yes or no, my children? Right. We got a value and c value, but we had to find b value to write the equation of the hyperbola. To find the equation of the hyperbola, we have to find b value. Do you remember the relation between a, b and c of a hyperbola, my children? Right. Now b square is equal to c square minus a square. So this is the relation between a, b, c of hyperbola. So in this equation, let us substitute c and b value, c and a value. Then what you will get? 3 square minus root 11 by 2 whole square. Understood this definition? Right. That is equal to 3 minus 11 by 4. Understood these two terms, my children? 3 square value is 9 minus root 11 by 2 whole square value is 11 by 4. Understood this step, my children? Right. That is equal to 36 minus 11 by 4. By taking LCM of the denominators, and we get the numerator 36 minus 4 9s are 36 minus 11 by 4. Understood this step, my children? Right. That is equal to 25 by 4. By simplifying these numbers in the numerator, 36 minus 11, what will you get? 25 by 4. We wrote the denominator as it is. Okay, my children. This is the value of b square. B square is equal to 25 by 4. Okay, my children. Right. B square value is 25 by 4. Therefore, the equation of the hyperbola, is y square by a square. What is a square? We get a by a square minus x square by b square is equal to 1. Okay, my children, in this equation of the hyperbola, we substitute a square value and b square value. Okay, my children, right. That implies y square by 11 by 4 minus x square by 25 by 4 is equal to 1. Here we substituted a square value and b square value. Understood this statement, children? Right. This implies y square minus 44 x square is equal to 275. By taking the LCM and we simplifying this equation, finally we get equation of the hyperbola is y square minus 44 x square is equal to 275. Understood this step, my children? Right. Let us take another example to understand the concepts of the hyperbola well. Okay, my children, find the equation of the hyperbola where foci are 0, comma, plus or minus 12 and length of the latest rectum is 36. Understood this question, my children? Here vertices of the foci were given and length of the latest rectum of the hyperbola was given. Then we have to find the equation of the hyperbola. Okay, my children? Right. By observing the coordinates of the foci of the hyperbola, here x coordinate of the foci is 0. So these foci lie on y-axis, means the transverse axis of the hyperbola is along the y-axis. Then the equation of the hyperbola will be y square by a square minus x square by b square is equal to 1. Okay, my children, this is the required equation of the hyperbola in which we had to find the values of A and B. Understood this point, my children? Right. Now come to the solution part. Since foci are 0, plus or minus 12, it follows that C is equal to 12. Yes or no, my children? These are the coordinates of vertices foci of the hyperbola. So what are the coordinates of the foci of the hyperbola? 0, C, 0, minus C. So C is equal to here 12. Understood this statement, children? So we got the value of C here. Okay, my children? Right. What is given here? Length of the lattice rectum of the hyperbola, that is equal to 2b square by a is equal to 36. Okay, my children? From this equation we get value of b square. This is the formula to find length of the lattice rectum of the hyperbola, that is equal to given as 36. Okay, my children? From this equation we get b square is equal to 18a. Understood this statement, children? Right. Therefore C square is equal to a square plus b square. This is a relationship between a, b and c of a hyperbola. So in this equation let us substitute c value and b square value. Then we get here c square, that is 12 square is equal to 144, is equal to, we don't know the value of a, so a square plus what is the value of b square here? 18a we found here. Okay, my children? Understood this step? Right. This implies a square plus 18a minus 144 is equal to 0. We rewrote the terms of this equation. Then we get a square plus 18a. We transpose 144 to RHS. Then it becomes minus 144 is equal to 0. If you observe this equation, this is a quadratic equation in A. Yes or no, my children? Do you know how to solve a quadratic equation in one variable? Yes, in the previous chapters, complex numbers and quadratic equations, you have learned. Yes or no, my children? Right. By using the previous knowledge, let us find the roots of this quadratic equation. Let us find the values of a. So we get a is equal to minus 24 or 4. These are the two values of a. Yes, are my children? And more over here, a is equal to minus 24. A value should be always positive. Okay, my children? We ignore the negative value because here a denotes length of the half of the transverse axis. Yes, sir, my children. So we take only positive value. Since a cannot be negative, a value cannot be negative value, we take a is equal to 6. Understood this step, my children? Why we are taking a is equal to 6 only? A is equal to minus 24 is ignored because a value cannot be negative value, and that is why we have taken a is equal to 16. So we got a value here. Understood this step, my children? Now let us substitute a value in this equation. Then we get to b square value. Okay, my children? Right. Then b square is equal to 108. So now, my children, 18 into 6. 18 6 are 108. Understood this step, my children? So we got a value and b square value. So then we can write the equation of the hyperbola easily. Therefore, the equation of the hyperbola, required hyperbola, is y square by a square minus x square by b square is equal to 1. Okay, my children, in this equation let us substitute the values of a square and b square values. Okay, my children, This implies y square by, what is a value here? 6. So 6 square is 36 minus x square by b square. We found here b square value is 108. So by 108 is equal to 1. Understood this step, my children? Right. This implies 3y square minus x square is equal to 108. By rewriting the equation of the hyperbola, finally we get 3y square minus x square is equal to 108. Understood this step, my children? Right.